Hey everyone, welcome back to The Explainer. So, we talk a ton about how smart large language models are, right? But I've always kind of wondered, how do they actually interact with the real world? Like, how do they read your calendar, pull a specific query from a database, or actually ping a message over to your team? Well, today we're diving into a genuinely elegant solution to this whole puzzle, the universal adapter behind MCP. Okay, let's dive right into this. How does an AI actually talk to your apps? Look, we have these incredible, powerful reasoning engines, but out of the box, they're kind of just isolated in a digital void. They don't magically know how to order you a pizza or pull together a quarterly sales report. They need a bridge to interact with the software we use every single day. And honestly, this is the fundamental problem developers are wrestling with right now. And right now, that bridge, yeah, it's pretty much a nightmare of custom integration. Basically, a custom integration means a developer literally has to hand code specific instructions just so a model knows what tools even exist, let alone exactly how to call them. This means every single time, and I mean every time, you want your AI to use a new tool, a human has to sit down, wade through dense documentation, and write these bespoke, hand-coded function definitions. It's slow, it's painful, and it totally doesn't scale. So here's our roadmap for today's explainer. We're going to look at the AI integration problem, what an API actually is, MCFP as the universal adapter, why APIs just aren't enough on their own, and finally, the true power of composability. Don't worry if you aren't a hardcore backend developer, we're going to build this up from the basics. Section 1. The AI integration problem. The bottleneck of building AI agents. So here's a quick reality check for you. If you want a large language model to use, say, 10 different APIs, well, you traditionally have to handwrite 10 totally different custom integrations. Just think about the massive scaling issue here. The intelligence of when and how to call an API currently lives in the incredibly tedious glue code that you have to write. You're effectively spoon-feeding the AI. You're saying, okay, here's the exact shape of the data for tool A, and here is the totally different shape for tool B. It's a nightmare scenario for anyone trying to build a truly versatile AI agent. Let's move to Section 2 and see how this builds. What is an API, the current bespoke standard? Fundamentally, an API, or Application Programming Interface, is essentially just a contract for how one piece of software calls another. It's a really broad umbrella term. We're talking REST, GraphQL, SOAP, the whole shebang. But here's the major catch. Every single API is a completely bespoke contract. Stripe's API, Slack's API, Google Calendar's API, they all have completely different authentication schemes, entirely different endpoint structures, and wildly different data formats. When you interact with them, you practically have to learn a new language by reading the unique documentation for every single one. And this is exactly where the Model Context Protocol, or MCP, comes into play. It is a standardized protocol layer that sits right on top of those APIs, and it's designed specifically for how LLMs discover and use tools. I mean, this is a total revelation. MCP wraps around all those bespoke, super unique APIs we just talked about and exposes them to the AI in one single unified format. All right, Section 3, MCP, the universal adapter. Standardizing the connection. And this brilliantly illustrates the core concept. Just think of an API as an electrical outlet, and MCP is the universal adapter. Think about traveling internationally, right? Every country, or, in our software world, every company, has its own unique shape and voltage for an electrical outlet. That's your API. MCP is the universal travel adapter. Now, it doesn't generate the electricity itself. The API backend is obviously still doing the real work there. But it means your device, your AI client, can plug into absolutely any outlet without needing a custom-built wire for every single weird combination. It's a real game changer. Because of this adapter layer, from the model's perspective, an MCP server for Slack and one for Google Calendar look exactly identical. The AI doesn't need to learn all the weird quirks of Slack's specific REST API or Google's complicated authentication headers. The MCP layer presents them both to the AI with the exact same discovery mechanism and the exact same calling convention. It just sees a perfectly uniform list of tools with simple names, clear descriptions, and cleanly structured inputs. Now let's jump into Section 4, why APIs aren't enough, bridging the 4 technical gaps. Now, what's really interesting about this is, well, you might actually be wondering, why can't we just skip MCP entirely and have the AI use regular APIs directly? Well, there is a key mantra to memorize here. MCP doesn't replace the API. It replaces the custom integration code you'd otherwise have to write for an LLM to use that API. You simply cannot skip the API, because the API is what actually does the work. MCP just handles the communication, so you don't have to write all that tedious translation code. So why do we strictly need that extra layer? It comes down to bridging these four specific gaps. Number one, no standardized discovery. An LLM can't just read an API's documentation on the fly and guess how to use it. A human has to translate it into a tool definition. MCP standardizes that translation. Number two, fragmented auth and session models. Every API uses different keys, tokens, or custom headers, right? MCP universally handles how the client authenticates to the server. Number three, no common calling convention. APIs return literally everything from XML to completely arbitrary JSON schemas. MCP ensures inputs and outputs are always strictly typed and predictable, so the AI doesn't get confused. And finally, number four, APIs lack composability, which actually brings us perfectly to our next major point. Section 5. The power of composability, unlocking seamless AI tool use. Okay, imagine an AI agent that needs to take action across 3 totally different platforms in one single go. First, it needs to pull a document from Google Drive. Next, it needs to query a SQL database. And finally, it needs to post a summary of all that data straight to Slack. Traditionally, you'd be building 3 separate, super fragile SDK integrations and just kind of gluing them together. But look at how it comes together here. With MCP, the interface is completely uniform. The AI can fluidly mix all 3 tools in a single session, seamlessly passing data from one to the next, simply because they all look and behave exactly the same to the model. So the absolutely crucial point here is this. APIs do the actual work. MCP standardizes how an LLM discovers and talks to those APIs. You can't just swap one for the other because they are doing fundamentally different jobs. Think of it like this. The back-end API is the engine pulling the heavy levers. But MCP is the universal steering wheel that allows the AI to drive absolutely any vehicle effortlessly. We've seen how standardizing this connection removes basically the absolute biggest bottleneck in AI development today. The tedious friction of those custom integrations is finally fading away, making room for true seamless composability. So I want to leave you with this final provocative thought to ponder. Whenever tool, database, and application speaks the exact same language, what will your AI build next? Thanks so much for joining me on this explainer. I hope it sparks some new ideas for you, and I will see you in the next one.